what's up guys? So welcome to this series of question 8 November 2022, which is just one of the questions on the series that is up to come. We are still gonna do question 8 November 2021 and also question 8 November 2020 for grade 12 maths paper 2. It was a Euclidean geometry question. Let's have a look at this one here. It was in question 8. Let's have a look at it, read the diagram, and also see if we could be able to answer any of these questions. Please make sure that you fully understand the parallel lines, the theorems that are involved. How do you prove that this quad that is given here, it is a cyclic quad, you know, and also just the parallel lines and theorems that are around and involved around the circles as well, and also the congruency and the ratio thereof. All right, so now let's go ahead and read this question. In the diagram, O is the center. Okay, very good. This is our center of the circle. Always nice when they give us the center. MNRP is a cyclic equilateral, and SN is the diameter. So therefore, if this is the diameter, okay, already what does this mean? If this is the diameter, we already know angle at the center is twice angle at the circumference. You know, we must be thinking of something along those lines. Immediately when they talk about the center, you must be thinking angle suspended by the same segment, you know, opposite angle of a cyclic quad, things like that, guys. If you really getting lost, please make sure that you watch a video on this channel when it comes to Euclidean geometry, but I will explain as we move along. All right, so please stay tuned and watch this video until the end so that you don't get lost and you fully understand the question thereof. All right, the quad MS, and then where is MS here? Okay, we've got a quad MS, there it is there, and then we also have OR are drawn, and then radius OR. Where's the radius OR? So this is our radius right here. Great stuff. And then M2 rather is equals to 64. Great stuff. So now let's go to questions 8.1.1. It says here, determine, give reasons, the size of the following angles. They were looking for what? For P. So P is right here. If I'm just looking at this already, because P is sitting here at this corner, you also have got here also, and they told us that M N P R is a cyclic quad. Therefore, if you have got these two angles, they are opposite to each other in this cyclic quad. So thereof, these two angles here, because they are opposite to each other, we know that therefore, if we were to add these two angles, angle P plus M2 should give us 180. One of the reason being opposite angles of a cyclic quad, opposite angles of a cyclic quad. Okay, as stated, because they already told us that this is a cyclic quad. So therefore we know what is M2. M2 is equals to 64. We've got the total there, 180. Therefore we are looking for P. P should thereof be 180 minus 64, which gives us an angle of 1160. Okay, so therefore we know this angle is 1160. Okay, great stuff. So moving right along, I am going to follow the suggestion that was sent on the comment below, that whenever we move to the following question, we must use a different color. Here we go. 8.1.2, it says here we must look for M1. So there is M1 there. So let's have a look at this one properly. We have got M1, we have got M2 there. But remember, what did the question? The question said this is a diameter. Okay, the question said SN is a diameter. So if this is a diameter, and we know that the total angles here, they are equals to 180, The total here is 180. So we know that angle at the center is twice angle at the circumference. So therefore the total angle here should be equal to 90. So therefore what does this mean? This means that M1 plus M2 should therefore give us 90. We have got M1 as 64 plus we have got M2 rather. Okay, we have got M2 rather, so we are still looking for M1 here. Sorry about that, guys, but yeah, I think you guys get the drift. So the only thing we just need to do here is to solve this using algebra. 64 M1 90 minus 64 should give us, I'm getting 26 here. Guys, please go and revise and master these rules, especially the ones of a cyclic quad, parallel lines, and also that of cycles theorem. I am going to do a revision video rather, because I know that Euclidean algebra can be very challenging to some of us. So I will just definitely post out, and please stay tuned on this channel so that you see when we post that video that has to do with the summary of Euclidean geometry. All right, so moving right along, let's move to question 8.1.3. Question 8.1.3. Question 8.1.3, it says we need to find O1. Okay, let me just remove these ones here because we were using these ones to answer the previous questions. Okay, now the question says let's find O1. We already know what is here. It's what is 26. Okay, so what is O1? O1 is sitting right here at the center. There it is, O1. Okay, so what do we know? We know that this is the angle that is sitting at the center, because they said O is the center. So mathematically, according to the theorems, we know that angle at the center, which in this case is going to be O1, is equals to angle at the center is twice angle at the circumference, which in this case is going to be M1. Okay, so what is M1? M1 is 26. So therefore, oh guys, I'm sorry, I didn't state the reason here. The reason here on this previous question, it should be angle at semicircle. I forgot to state the reasons, guys. Can you see how easy it is to lose marks? Everything is correct, but I forgot. So on this one, the reason would be the reason will therefore be angle at center is equal to twice angle at the circumference. Okay, great stuff. So therefore 0.01, therefore when you put this into our calculator, what are we getting? We are getting that O is equals to 52 degrees. Okay, great stuff. So that's how you would deal with this one. Angle at the center is twice angle at the circumference. I hope you guys are really following. So now let's move on to 8.2. Now let's have a look at 8.2. 8.2 says that in the diagram, triangle ABG is drawn. Okay, we can see the triangle ABG where D and E are midpoint of AB. Okay, great. We can also see it's also marked here as well, and then AB and AG respectively are formed. All right, and then they said AG and BG are produced to C. AG and BG are produced to C. Okay, there's C there, and H respectively. Okay, there's another H there, and then F is a midpoint on BC such that FG and CH are parallel. Great. So now let's go on and look at the question. Question number 8.2.1. Give a reason why DE is parallel to BH. Let's have a look at one. BE, where did it say? No, sorry, DE. DE is that one there. It is parallel to BH. Okay. Okay, we must give a reason for this. All right, so let's look at this question now. We say 8.2.1. guys, if we have a look at 8.2.1 and you look at what they are referring to, it stated that in this triangle ABG, you have got DE as a segment. DE is a segment. So now if you have that as a segment in this triangle, which is this segment here that we just highlighted, therefore it divides, it forms a midpoint as stated there in the question. It forms midpoint with A, G and AB. Okay, let's see midpoint with A, G, where the L is G. Okay, G is here, and therefore and also with AB. All right, so there's a midpoint there. It cuts it at equal, there is marked there at equal dimensions. Okay, so therefore if we have that line that is cutting at the segment at equal dimensions, therefore DE should be parallel to BG. Okay, BE should be parallel to BG. Okay, so if we have that, therefore we would know that BG is equals to twice as DE. All right, so therefore this now you are using the reason this here will be midpoint theory. Okay, I hope you guys can still remember the midpoint theory. If you don't, please go watch the videos on this channel. We do explain the midpoint theory in detail. So therefore if you have that, it definitely means that therefore this DE is parallel to BH. Okay, great stuff. So I hope it's clear, guys. If it's not clear, please let me know. Right, so now let's move on to 8.22. Right, let's move on to 8.22. 8.22, it says 8.2.2. It says that if further given that, okay, if they give to us that FC all over BF is equals to 1 over 4 rather, and therefore they tell us that DE is equals to 3x minus 1, and therefore also GH is equals to x plus 1. Okay, so calculate and give reasons the value of x. Okay, so this is just the theorem of proportionality, guys. So we are going to come here and say, okay, if we're given that, let's look at, we're only gonna look at let me just try to make it clear here. Let's remove that. We are looking at this triangle here, BGH, and then BFC. We're looking at that triangle here and also that there. All right, so now but we're looking at the bigger triangle. Okay, let me rather remove this because we're looking at the bigger triangle. So the ratio there will say it was going to be BF all over FC is equals to BG all over GH. Okay, all over GH. However, we know from the previous question that we did that BG is equals to twice DE. Okay, so I'm just gonna substitute here, so mark clear here. So we know that this is also equals to twice DE. So okay, now let me write it properly here. BF all over FC is equals to twice DE all over GH. Okay, now we can substitute BF according to this is equals to 4 all over 1, which is FC is equals to DE, which is going to be twice 3x minus 1 as given there, all over GH is equals to x plus 1. Okay, so therefore now we can do cross multiply there. We are going to have 4x plus 1 is equals to twice 3x plus 1. Therefore, now we're only left with the algebra. 4x plus 4 is equals to 6x plus 2. Okay, then if we simplify this further, I'm going to take 4x to that side and then this one to this side. So this side I'm going to have 4 minus 2. This one I'm going to have 6x minus 4x. Therefore, we're left with 2 this side, and then this side we're left with 2x divided by 2 because we're looking for x, not 2x rather. Oh, okay, no, I made a mistake here. Let me see. This is a negative here, guys. It's a negative there. Sorry about that. So when I multiply throughout, this will be negative 2. And then that negative 2 when it comes to this side is going to be positive 2. Therefore, giving us 6 here. Oh, what a terrible mistake. Okay, but anyway, we managed to see that. That's the most important thing why we are practicing and we are doing this as well. Okay, so multiply throughout and then we get 2 there. Negative 2 comes this side is going to be 2. Then 6x minus 4x is going to be 2x divided by 2 divided by 2. Therefore x, let's see, x is going to be 3. All right, and that's how you would deal with a question like this one. I hope you guys really understood this, and also the proportionality theory. I think this question was a very nice question, very nice and not that tricky, but it did explain what we need to know and what concepts are critical in this chapter as well. Please let me know what you guys think, and I will see you on the next upload where we'll be doing question 8 November 2021.